Okay, welcome, ladies and gentlemen, right into all of our trigonometry stuff. We're going to look at the 6 trigonometric functions, and we're going to be doing a lot of math in this sort of stuff today. A little bit of new stuff, a little bit of not new stuff. All right, so let's go ahead and look at what are the functions that we're going to be dealing with. So there are 6 trigonometric functions. You might remember the 3 from geometry, algebra 1, whenever you first learned SOHCAHTOA, right? You learned SOHCAHTOA way back, I don't even know back when now, representing something to do with sine, cosine, and tangent. Now we're going to add the other 3. So we get sine, cosine, tangent. We get cosecant, secant, and cotangent. All right, so cosecant is CSC, secant is SEC, and cotangent is COT. So we have right triangles. We're going to look at these 6 things. We're going to give you a right triangle, and given this theta down here in the corner, we're going to represent each of the sides with regard to theta. And I know that the side over here is opposite, the side down below is adjacent, and the big long side is my hypotenuse. So I know this already. These are things that we remember from geometry. So here's our 6 ratios, so fractions. Sine represents, the sine of theta is going to be the opposite over the hypotenuse. Cosine is going to be the adjacent over the hypotenuse. And we're talking about lengths, so whatever the length of the adjacent side is, divided by the length of the hypotenuse. And the tangent of theta is opposite over adjacent. And then what you're going to find out is cosecant is just the reciprocal of sine, so hypotenuse over opposite. Secant is the reciprocal of cosine. And likewise, cotangent is the reciprocal of tangent. So it's very handy that we understand which ones are reciprocals of what. Okay, so sine goes with cosecant, cosine goes with secant, and kind of obviously, tangent goes with cotangent. All right, so let's try some stuff here. So I want to find the values of the 6 trig functions of theta. So basically saying, I'm going to say, what is the sine of theta? Well, in this case, I need opposite of theta divided by hypotenuse. Well, I don't have hypotenuse yet, but I'm pretty sure we could figure out using a very simple Pythagorean theorem. 4 squared plus 3 squared equals the square root of 16 plus 9 is 25. So it's 5. So sine of theta is opposite over hypotenuse, so it is 4 over 5. Cosine of theta. Cosine of theta is adjacent over hypotenuse, which is 3 over 5. Tangent of theta, opposite over adjacent, so 4 over 3. And I continue with this, going cosecant is the reciprocal of sine, or in other words, hypotenuse over opposite. Secant of theta is the reciprocal of cosine, or in other words, hypotenuse over adjacent. And cotangent theta is the reciprocal of tangent, or in other words, adjacent over opposite, which is 3 over 4. So let's try a different one. Now, I notice I don't have what would be technically the opposite side, so I do need to use Pythagorean theorem here. So 10 squared minus 5 squared, right? Because a squared plus 5 squared equals 10 squared. So this would be the square root of 100 minus 25, which is 75, reduces to 5 root 2. Or sorry, 5 root 3. Oops. All right, so let's think about this. Sine of theta. Theta is over here in this corner, so opposite divided by hypotenuse is 5 radical 3 over 10, which would be root 3 over 2. Cosine theta is going to be 5 over 10, which is equal to 1 over 2. Oops. Tangent of theta is opposite over adjacent, so 5 root 3 over 5. I get 5's cancel, so I get radical 3. Moving right along, cosecant of theta is the reciprocal of sine, so 2 over radical 3, but we're not allowed to leave radicals in the denominator, so I have to multiply by root 3 over root 3, and I get 2 root 3's over 3. Secant theta is the reciprocal of cosine, so I get 2. And cotangent theta is the reciprocal of tangent. Since this is root 3 over 1, it becomes 1 over root 3. But I have to do that multiply by a fancy form of 1, and I get root 3 over 3. Okay, so that's pretty straightforward, I think. Pretty easy. No, my stuff's not deleting today. All right, so let's look at some special angles. First special angle that we're going to deal with is the 45. And if you're given any 45, 45, 90 triangle, this will help us determine what is the sine, cosine, tangent, and the other three of 45. These are ones that we're going to want to try to memorize to the best of our abilities. I will also give you guys the hand trick when you guys come to class next, and we'll be able to use the unit circle. But right now, let's look at it with respects to a triangle. So if I let each of the legs equal to 1, and I know I can because it's 45, 45, which means it's isosceles. If I let this equal to 1 and 1, I know from the Pythagorean theorem that this means this is root 2. 1 squared plus 1 squared is 2. Square root gets root 2. Which means I can do the sine of 45 degrees. The sine of 45 degrees is going to be 1 over root 2. But I can't leave the radicals in the bottom. So I get root 2 over 2. That's a very special number for us, root 2 over 2. Cosine of 45 degrees. Well, cosine of 45 degrees is adjacent over hypotenuse, which is also 1 over root 2. So it still comes out to root 2 over 2. I'm going to go ahead and write that in there. Tangent of 45 degrees is opposite over adjacent, so that's 1. Oops. Cosecant of 45 degrees. Cosecant is the reciprocal of sine. Sine is 1 over root 2, so cosecant is going to be root 2. Well, nicely in this case, secant is the same thing because cosine was the same thing. And, dang it. Cotangent 45 is the reciprocal of 1, so it's just 1. So these are very special numbers for us, as I was saying. Ones that you're going to become familiar with. And at some point in time, I'm going to say, hey, what's the sine of 45 degrees? And you're going to be able to say root 2 over 2 with not too much thinking. You also have to recognize that this doesn't only mean 45 degrees. This could be pi over 4. 45 degrees is pi fourths. So the sine of pi fourths is root 2 over 2. All right, cosine of pi fourths is root 2 over 2. Tangent of pi fourths is 1. So you need to be able to convert between degrees and radians here interchangeably. 45 degrees is the same thing as pi fourths. Let's move to the 30, 60, 90 triangle, the one we learned in geometry. The other one we learned in geometry as well. This one had some special qualifications here on your sides, or special ratios on your sides. If you let the shortest leg equal to 1, we got some very special properties. The first is that the hypotenuse is twice the length of the shortest leg, and that this side is root 3 times the length of the shortest leg. So you can verify this. There's other ways to verify this, but I'm going to go with our stuff we learned in geometry on side lengths of a 30, 60, 90 triangle. So I'm going to say, okay, what is sine of 30? Let's start with sine of 30. Sine of 30 is going to be across from the 30, so opposite over hypotenuse. So it's going to be 1/2. Cosine of 30. Cosine of 30 is going to be adjacent over hypotenuse, so root 3 over 2. And tangent of 30 is going to be 1 over radical 3, which ends up being root 3 over 3. Cosecant of 30 is the reciprocal of sine, so that's 2. Secant of 30 is the reciprocal of cosine, so it's 2 over radical 3, which becomes 2 radical 3 over 3. And cotangent of 30 degrees is equal to, well, the reciprocal of tangent, which would be radical 3. So that's the 30 degrees, and again, these are very special numbers for us. 1/2, root 3 over 2, root 3 over 3. These are very special. Remember that also equals for the 30-degree angle. The 30-degree angle is the same thing as a pi over 6 radians. So let's look at the 60-degree angle now. Sine of 60 is... Here's the 60 now, so it's opposite over hypotenuse, so root 3 over 2. Cosine of 60 is adjacent over hypotenuse, so it's 1/2. Tangent of 60 is opposite over adjacent, so root 3. Cosecant of 60, reciprocal of sine, so 2 over radical 3, which is actually 2 radical 3 over 3. Secant of 60 degrees is the reciprocal of cosine, so 2. And cotangent 60 is the reciprocal of tangent, so it becomes 1 over radical 3, which actually is root 3 over 3. And again, 60 degrees is the same thing as pi thirds. So sine of pi thirds is root 3 over 2. These are numbers, like I keep saying, that you are going to become familiar with. You should know that the sine of 30 is 1/2. That's just one of those numbers. That's the first one that usually people memorize. Sine of 30 equals 1/2. But what I want you to kind of think about is sine of 30 is 1/2, cosine of 60 is 1/2. Notice the thing here. I mean, sine of 30 is the same thing as cosine of 60. Cosine of 30 is the same thing as sine of 60. There might be something there. There is. I just want you guys to think about it before I say anything, because we're not going to look at that just yet. All right, so we've done the 45, we've done the 30, we've done the 60. Let's move forward, see what else we're going to look at today. Okay, we're going to look at what's called the fundamental identities. And I'm going to pass out a handout cheat sheet for all of the identities. We're just going to look at the first three basic ones. One of them being the reciprocal identity, basically saying that sine theta is equal to 1 over cosecant theta, or cosecant theta is the reciprocal of sine theta, that sort of idea. One of the other ones, the really big one, is this. Sine squared theta plus cosine squared theta equals 1. This is called our Pythagorean identity. Okay, because it kind of looks like a squared plus b squared equals c squared, which is correct. That's where it comes from. But I want to show, the third one that we're going to look at is the fact that tangent of theta is equal to sine of theta over cosine of theta. And you can verify that from one of the other triangles that we dealt with earlier. But here's my example. I'm going to say let theta be an acute angle such that the sine of that theta is equal to 0.6. And I want to find the values of cosine and tangent using trig identities. So I have to somehow compare sine to either cosine or tangent. Now I do know, and this is where some of you guys are going to go, I do know that tangent is equal to sine over cosine. The problem is, I only know what sine is. That leaves two variables. So that's not the one I want to do. But I do know that sine squared theta plus cosine squared theta equals 1. I know what sine theta is. Well, you guys do have to you have to know this, by the way. This is little. Sine squared theta is the same thing as taking sine of theta and then squaring the whole thing, which means sine of theta is 0.6 squared plus cosine squared theta equals 1. 0.6 squared is 0.36. I get cosine squared by itself. I get 0.64. Take the square root of both sides. I get 0.8. So I figured out cosine. The question was find cosine. Okay, so I know cosine. But it also says find tangent. Well, now I can look at tangent is sine over cosine. So tangent is equal to 0.6 over 0.8. Knowing how to do math tells me I can make that 6 over 8, which is actually to 3 over 4. And if you want to keep the theme, 0.75. Let's try another one. Let theta be an acute angle such that the tangent of that theta equals 3. Find the value of cotangent and secant using trig identities. Well, I know that tangent and cotangent are very similar in the fact that they are reciprocals of each other. So if tangent theta equals, where'd that come from? If tangent theta equals 3, then cotangent theta is 1/3, the reciprocal of 3. And I also have a Pythagorean identity that compares secant to tangent. So we're going to use the same thing we did before. Let's see if I can remember it off the top of my head. That'd be nice, but apparently I'm not going to be able to. I know that 1 plus tangent squared is equal to secant squared theta. So 1 plus, okay, so tangent is 3, squared would be 9, equals secant squared theta. Square root gets me radical 10 equals to secant theta. We have now answered both questions asked of us. Okay, before we solve this, I will tell you, you will need a calculator. So hopefully you have a calculator somewhere handy. And hopefully you know how to use your calculator. You're going to want to find the sine, cosine, and tangent buttons on your calculator. You'll notice that there are no secant, cosecant, and cotangent buttons. And notice that we're in degrees, so your calculator needs to be in degree mode. So I'm going to do a little bit of math here, and hopefully we can figure out what that means. So a surveyor standing 50 feet from the base of a large tree. He measures the angle of elevation to the top of the tree is 71.5 degrees. Now I know how tall the tree is. Well, you might be interested in knowing this is really kind of how trees are measured. Some of you are like, why the hell do you not know the height of a tree? But some people want to know. Okay, we're going to assume this tree is over here. It's standing straight up and down. And the surveyor is out here somewhere. He's looking up at the top of the tree. And he is 50 feet from the base of the tree. Now, you need to know where the angle goes. The angle is going to be here because he's measuring from the ground up. That's why it means elevation, so 71.5 degrees. You might recall doing this in geometry, which is good. You got a leg up on some of the other people that don't remember their geometry classes. Now, if I look at 71.5 degrees, I have the opposite side and the adjacent side. So that tells me to use tangent. So the tangent of 71.5 degrees is equal to opposite over adjacent. Now I'm solving for x, so I have to multiply both sides by 50. And I get 50 tan 71.5 equals x. Now you're going to want to plug into your calculator tangent of 71.5. You don't necessarily have to do this first, but I want you guys to get, I want to make sure you get 2.9887 rounded there. And if you're not getting 2.988, just let me know tomorrow and I'll make sure everybody knows how to change their calculators. Okay, so multiply that number by 50. I get that the tree is 149.43 feet tall. Okay, so that's solving a very basic right triangle. One that we probably did in geometry class a couple years ago. What about something like this, if I want to ask you to solve for theta? Now, this gets a little bit more challenging, but nothing outside of what I think we can do. So if I look at theta here, I have the side adjacent and the side hypotenuse. So adjacent and hypotenuse tells me to use cosine of theta. Cosine of theta is going to be opposite over hypotenuse, or sorry, adjacent over hypotenuse, so 200 over 400. So that tells me that cosine of theta is equal to 1/2. Now, if you recall, one of our special right triangles said something about cosine of some angle equals to 1/2. Well, it just turns out that it was 60 degrees. Now, this one's a super nice question because you didn't have to use your calculator. All right, the cosine of 60 degrees is 1/2. So the answer is 60 degrees. But things don't always come out nice, as you might understand. What if the number was 500 instead of 400? Well, same process required. So cosine of theta is 200 over 500. Which is actually 2 over 5. But none of our special angles said anything about 2 over 5. So here's where you have to use a special button on your calculator called cosine inverse. In order to undo cosine, I need to do cosine inverse. So theta is going to equal cosine inverse, this cosine to the -1 here, of 2 over 5. So find that button. If you don't know where that button is, I'll show you guys tomorrow when you guys come in class. 2 divided by 5, I get 66.42 degrees. All right, and if you're not in degree mode, you're not going to get that particular number. But again, I will show you how to change your calculator in class tomorrow. All right, so that wraps up for our right triangle trig. There's a lot of stuff to do. There's a lot of stuff to get up tomorrow. I'm going to leave you guys with this. Only a couple of you will probably get this, but all right, I will see you guys tomorrow.